All right, so today we're continuing on with 14.2, which was about combinations and permutations, but now we're actually combining the combinations and permutations together into multiple combinations and permutations, and we will also be working on this idea of labeling. So by the end of this, you need to be able to find the number of arrangements for a multiple combination permutation, and also be able to find the number of arrangements for a labeling problem and identify them as labeling. So let's just start out with the multi-combinations and permutations. So multiple types of items can get arranged separately from each other and then combine to make an overall pattern. And that's really this idea of the multiple combinations and permutations. This idea that we could separate things out and say, okay, we can combine these items, we can do a combination of these items, and then together they create an overall pattern. When this happens, you will need to combine multiple permutations or combinations. In order to do that, we really have some basic steps to think through. First, and probably the most important one, is to identify if order matters. Identify if order matters. Just like we were doing yesterday, knowing if order matters will determine, is this a permutation or is this a combination? If order matters, so order does matter, then it's a permutation. If order does not matter, then it's a combination. And that will tell us our starting point. Okay, once we determine that, we are going to simply so let's do these steps as we read through this first example. Okay? So, looking at number 1, Mr. Roberts is arranging pictures of faculty into a slideshow. He has 8 pictures from the math department. He has 6 pictures from the English department. He has 15 from foreign language and 4 from science. If he plans to keep each department together, but put the types in order of math, then English, then foreign language, then science, then how many different arrangements are possible? So, if I'm getting put into a slideshow, do I really care if I'm the first one in the slideshow or the last one in the slideshow? No. So in this case, well, I don't really care what happens, but doesn't the order determine what the slideshow looks like? So if we're putting the math department and we're saying what's the order that they can be put in order to create this, right? So we're changing the order of the pictures, and the whole idea behind this is what's the order going to look like in the end because we're arranging them, right? So order does matter. So order matters because it will change. Order matters because it will change / determine what the slideshow looks like, right? So since we're putting things in a slideshow and we're really paying attention to what order they're going in, that means order matters, which makes this a permutation. So permutation for this first one. Well, now that I know that it's a permutation, we have to think, what am I going to care about next? Well, second, we are going to calculate each permutation / combination. So in this case, we already have a basic order, right? It's math, then English, then foreign language, and then science. So we're going to start out with that, and we're going to find a permutation of each one of those, because we're not combining the math with the English, with the foreign language, with the science. They're just doing math, then they're just doing English, then they're just doing foreign language, then they're just doing science. So we're going to look at these as each separate and calculate the ways that those can each be ordered together. So we're going to do a permutation of math. Well, math was 8 pictures. So we have 8 pictures from the math department, and they're going to use them all. So we have 8 options that they're going to choose 8 from. So then we have to go to our calculator, right? 8, go back to probability, choose the permutation, and we're choosing all 8 of them. So we get 40,320. So 40,320 for this one. Then we're going to go ahead and we're going to do the English, which there are 6 English. So there are 6 options that we're choosing all 6 from. So we're going to do that again. So 6 math permutation, and we're choosing all 6. So 720. Then for foreign language, we see that there are 15 from foreign language. So we have 15 options that we're choosing 15 of. So we're going to do that again. So 15 math permutation, choose 15. So this one's a really long one, so we're just going to write that as 1.308, because it was 7, 6, right? So 1.308 times 10 to the 12th power. And then for science, it looks like we have 4 pictures from science. So we're going to have 4 options that we're going to choose 4 of. So we're going to go back to our calculator again, right? 4 math permutation 4 is 24. So now these are all the different ways that we can arrange just the math, just the English, just the foreign language, just the science. But then we're going to combine them all together. And since we're combining them all together, we would do that by multiplying. So multiply all permutations / combinations together to get total number of arrangements. So I would be doing 40,320 times 720 times 1.308 times 10 to the 12th times 24. So now we're going to go ahead to our calculator and type all that in, right? So 40,320 times 720. I'm going to skip this because order doesn't matter, and I'm just going to do times 24. Then I'm going to do the scientific notation in parentheses, so 1.308 times 10 to the exponent of 12. And my I had to arrow out of that, so arrow out into the parenthesis for the overall. And we got 9.11 times 10 to the 20th. So there's that many arrangements. Okay, so let's look at number 2 together as well. So let's read it to decide. Remember, first thing we have to do is identify, is it a permutation or is it a combination? So in a group of 14 preschoolers, the teacher will randomly assign 5 students to the unicorn group, 6 students to the dinosaur group, and 3 to the giants group. So we've got 5 unicorn, 6 dinosaur, and 3 giants. So it doesn't matter what order I get put into a group at. So if I'm getting put into the unicorn group, does it matter whether I was the first one, the second one, or the third one put into the unicorn group? No, it doesn't matter what order I go into the unicorn group. It just matters that I was in the unicorn group, or matters that I was in the dinosaur group, or in the giants group. But it doesn't matter whether I was the first, second, third, fourth, or fifth student assigned to that group. So this one is order does not matter. Just what group you're in. just group, not when assigned a group. So that means that this is a combination. Okay, so we're looking at a combination here, right? So that means we kind of have to look at this as we have three different groups happening here, right? We have people going into a unicorn group. We have people going into a dino group. And we have people going into a giants group. So let's think about the unicorn group. When I do this, well, first of all, I need to know how many total options there are. So I have 5 students and another 6 students and another 3 students. So there are 5, 11, 14. There are 14 students in total that we are going to get to choose from. So if I assign the unicorn group first, I have 14 options, of which I am choosing 5, right? So before I even type that in the calculator, let's just do that for each one. Now we need to be careful here, because once I choose 5 of them, do I still have 14 kids to choose from? No. So when I do the dino group, I really only have the 6 plus 3 left, which is 9. So at the dino group, I have 9 options, and I'm going to choose how many? They said 6. Then when I get to the giants group, I don't have 9 or 14. I only have the 3 that are left. So I will have 3 left, and I will choose 3 of them. So when you're doing these, you have to be careful, because once you do one of them, you have to realize if I've already taken 5 of my choices, that means I don't have 14 anymore. I'm now down to 9, because 14 minus 5 means 9 are left to choose from. And then when I choose 6 of them, those 6 have already been assigned to a group, so I don't have 9 left to choose from. I have 9 minus 6, which means 3. And since there were 3 getting assigned to the giants group, then it's 3 choose 3. So now we can type each one of those into our calculator, right? 14 choose 5 is 2002. 9 choose 6 is 84. And 3 choose 3 is 1. And now that we've got those, we're going to take each one and multiply them together. So 2002 times 84 times 1. So 2002 times 84 times 1 is 168,168. So that's how many ways there are to assign those preschoolers to their groups. Now you're going to look at number 3, and you're going to try number 3 on your own. And we'll go over it tomorrow in class. Then you're going to pause the video, or you're going to go to the next video once you've tried number 3.